Right. Good afternoon and welcome to the first webinar of 2025. Hopefully I can remember to say 2025. I'm Matt Helmers with Iowa State University, the Iowa Nutrient Research Center, and a faculty affiliate with Iowa Learning Farms. Thank you all for taking time out of your schedule to attend one of our webinars and in the inaugural one for 2025. I'll put a plug in that if you have a topic you would like to hear about in the future, please email us at the Iowa Learning Farms. Specifically, Elena Whitaker would be the best point of contact for webinars. We're always looking for topics that fit into this webinar series. So nobody got on to hear me talk today, and so we are really fortunate to have Dr. Adam Janke with us today. Dr. Janke is a faculty member here at Iowa State University with research and extension responsibilities, maybe teaching as well. Adam, I don't know. Are you three-way appointment? But we hear a lot about water quality wetlands in Iowa and some of the water quality benefits of that. But Dr. Janke's been looking at the ecology of these water quality wetlands. And so I think a really, really timely topic, and a couple of his pictures can make us think of nice warm weather as well as we're sitting here on a kind of a cool day in Iowa. With that, I'm going to turn it over to Dr. Janke. And if you have questions or comments, please type those into the chat box and we'll get those to Dr. Janke at the end of the talk. With that, the virtual floor is all yours, Adam.
Awesome. Thanks, Matt. And thanks, folks, for tuning in. Yeah, on a cold, snowy day, we're going to zip back to the spring breeding ecology of these wetlands and explore some of the work that we've been doing over the last couple of years on water quality wetlands and nearby restored wetland ecosystems in north central Iowa. And then I'm going to talk about what we're finding in the first couple of years of bird work on these systems, and then preview some work that we're excited to be doing for the next couple of years as well. So thanks for the opportunity to join you here, and look forward to the opportunity for some questions at the end as well. So first, I just wanted to acknowledge a whole bunch of people. Like, I'm just the voice here, as is often the case. Science is a very collaborative process, and that's certainly the case with this project. There's been a lot of people involved and funders to acknowledge. So I just wanted to mention that. First and foremost, our work is almost exclusively on privately owned land. And so I just want to acknowledge the generosity of the landowners that allowed us access to their properties to do this research and to inform this conversation about water quality wetlands in the state. And then I also wanted to mention that the Iowa Department of Ag and Land Stewardship facilitated the access to that land and finding the wetlands as well. Then the graduate student that has graduated as we like and gotten a job as we also like. She's now managing wetland ecosystems in northern Minnesota. And so much of what I'm presenting today is the hard work of Evie von Bachman, who finished her graduate degree in our program last fall and has started, like I said, with the Minnesota DNR. And then a big collaborative team of both field technicians and researchers at Ducks Unlimited and Iowa State designed and implemented this study. Other researchers here at Iowa State, Sarah McMillan and Anna Tucker, have helped with it, and it was funded by the U.S. Fish and Wildlife Service's Prairie Pothole Joint Venture and by Ducks Unlimited. So I just wanted to get all that out of the way to acknowledge the important contributions of a whole bunch of people that I'm going to try to be reflecting their work and contributions today. The task at hand today is to talk about wetland restoration. And so I thought it'd be kind of fun to rewind a little bit with a picture of a restored wetland, actually from central North Dakota. And so what's going on here is not a circus instead, and this is from 1988, the celebration of a wetland restoration in central North Dakota, along the time that the United States, Canada, and Mexico signed on to the first North American waterfowl management plan, which had at its core an effort to restore wetland ecosystems for breeding waterfowl. What I wanted to share with you about the story of this cool wetland restoration in North Dakota is how central wetland conservation and agriculture has always been to wetland conservation. We're always looking for ways to find opportunities to integrate wetlands back into agricultural landscapes where they've been drained and lost, in ways especially to find mutual benefits for producers and the environmental good that wetlands do. And so I just love this sign. A colleague of mine, Dave Case, was recently telling me about this celebration that was held the year after I was born in North Dakota. And I just love this sign in the remarks of dignitaries at this meeting. You can see the Mexican flag in the background celebrating the international collaboration for wetlands in agricultural landscapes, and how we can have profitable and thriving agriculture and abundant wildlife with wetland ecosystems. Here, the dignitaries are pouring a vial of soil that was once excavated to drain the wetland back into the drainage ditch, and those vials of soil were mailed to all the participants to bring along. And then, of course, a bulldozer came in and undid the work that a bulldozer or a couple of shovels had done years before to restore this one wetland ecosystem in 1988 in North Dakota. I just thought that was a cool story about the integration of agriculture and wetland conservation that goes back at least my lifetime and lifetimes before that as well. The other thing I wanted to mention is that here is a point in a data file that I'm getting ready to share more with you that Ducks Unlimited provided us at the conception of this project that I'm talking about today. And that point is also from 1988, and it was the oldest point I found in that data set. Ducks Unlimited has been restoring wetlands in North America since the 1930s, but their records that they shared with us that informed this research project started in 1988. So I thought that was a cool connection to that North Dakota case study, and a connection here to Iowa, where, again, wetland restoration has been ongoing in agricultural landscapes like this wetland in Dickinson County for quite some time. And the footprint of Ducks Unlimited's work as one of the players doing wetland conservation in Iowa looks like this. This is 1,400 cases where Ducks Unlimited has been involved in some sort of ecological restoration, wetland, grasslands, and associated ecosystems, floodplain forests, and others around the state. And so this is Ducks Unlimited projects from 1988 to 2021. Well, we know other people are also talking about wetland conservation and restoring wetland ecosystems. And what I think regular attendees on the webinar will be familiar with is this paradigm of designing and implementing water quality wetlands. Here in Iowa, we call them CREP wetlands because that's one of the funding mechanisms, Conservation Reserve Enhancement Program here in Iowa, or Water Quality Initiative wetlands or the like. Here's the records that IDAL shared with us at the beginning of this project. They started building these wetlands in 2002, and here, as of 2021, when we started this project, was the geographic distribution of those wetlands. These two different paradigms are going to be what I explore through an ecological lens today in the presentation. One is the water quality wetlands, and you see I put that in quotes, and I'm going to stop putting it in quotes from here on out because all wetlands are good for water quality, but like some wetlands are designed to receive a bunch of nitrogen in water. And that's what I'm calling a water quality wetland, or these constructed wetlands that were all those blue dots on that last map. The other quotes, wildlife wetlands, because as we're getting ready to establish, all wetlands are good for wildlife too, and water. Wildlife wetlands tend to be more of what we call a restoration paradigm. What I say here is like, this is like putting wetlands where glaciers put them, or putting wetlands where time, like centuries of geomorphic processes put them. These two paradigms are playing out on the landscape in Iowa in concert. We have wildlife, wetlands that are sort of restored with a first order priority for wildlife being restored in landscapes right next to wetlands that are constructed with a first order priority of addressing nutrient losses from agricultural landscapes, like water quality wetlands through the Conservation Reserve Enhancement Program. And so our study wanted to take advantage of this and just sort of admire the ecology, focusing mostly on birds and things birds care about, of these two different wetland types that occur in these landscapes in close proximity. So for the rest of the talk, I'm going to talk about water quality wetlands, which are nutrient treatment wetlands constructed to receive high concentrations of nutrients in subsurface drainage water primarily, and facilitate denitrification, primarily funded in Iowa through CREP, or Water Quality Initiative, and created between 2002 and 2019. And we constrained it to just those sites that were less than 11 hectares, which I should have converted that to acres. It's like 25 acres, basically. Then we also paired it with a nearby restored wetland that was restored with the first order priority of wildlife conservation. And so this is, I'm just showing you in a 1.5 mile section here with this figure where this could be playing out in our landscape. The lower wetland is one restored by Ducks Unlimited. The upper wetland, the northern wetland, is a water quality wetland. We constrained those wetlands that Ducks Unlimited has been involved with just to those that are 25 acres or 11 hectares, and just to those restored in the same period that the Iowa Department of Ag and Land Stewardship was doing the water quality wetlands, to sort of facilitate this case study of studying wetland ecology across the state, to understand these two different types and how they're contributing to wildlife conservation. And so here's the result. We gained access to 23 water quality wetlands and 23 paired wildlife wetlands for a total of 46 wetlands. And we went to these throughout the Iowa portion of the prairie pothole region, or what in Iowa we know as the Des Moines lobe. So we focused just on prairie pothole landscapes because our funding was from the U.S. Fish and Wildlife Service's Prairie Pothole Region joint venture. We went to these wetlands a bunch of times during 2022 and 2023. We did bird surveys that I'll talk about in more detail. And we also sampled the wetlands themselves for fish, vegetation, and depth characteristics that I'll talk more about. Our marsh bird surveys we followed the standardized North American marsh bird monitoring program. So we schlepped out into these wetlands like pictured here with Bellamy, and we sat for 13 minutes. The first 5 minutes were in silence. And then the last 8 minutes, we played vocalizations of birds that elicit callbacks from really secretive or hard to observe birds like soras and Virginia rails. And so we listened for a total of 13 minutes, and we did it twice during May and June on every single one of these wetlands, all 46 wetlands in both years. And we were looking, and I'll present, and we were looking for any birds theoretically, and I'll show you all the birds we heard and saw. But we were looking primarily for what we call marsh birds, these birds that breed in wetland vegetation. And this is the species that I'll present an analysis for, because these are the species that we had enough data to analyze for it across both wetland ecosystems, or both wetland types. So swamp sparrows, soras, marsh wrens, red-winged blackbirds, common yellowthroats, American coots, pied-billed grebe, Virginia rail, and yellow-headed blackbirds all rely on wetland ecosystems to breed, and we'll focus on them when I speak of marsh birds. I will mention, I'm not going to mention red-winged blackbirds and common yellowthroats again, because they're like the most abundant birds, some of the most abundant birds in Iowa. They were on every single one of these 46 wetlands, so there's not much to say there. But the rest of the birds, we'll talk about some of the variation. Then we went back to the wetlands in June and July, and we flew a drone over the wetlands looking for broods of waterfowl. Most of these waterfowl that we were looking for with these drones nest in grasslands or nest in cavities, and then they move their broods to the wetlands to feed and grow. And so we wanted to, you can't really survey them any other way. So you have to go find them after they've hatched and when they're out on the wetlands. And we saw one other species of waterfowl, ruddy duck, but it was only on one wetland. So you're going to see me talk about these 6 species the rest of the time. The other thing I just wanted to share with you, I hope this is playing okay through Zoom, but this is what the reason we use these drones to do these surveys. What you're seeing is on the left is the same brood filmed on the right. The brood on the right is being shown in true color, and the brood on the left is being shown in thermal. And that's why we use these thermal cameras. You can see how those birds on the water really stand out, and it allows us to really effectively survey waterfowl use of these wetlands, even when they're hiding in vegetation like they are currently on that video. This is another video I thought would be fun to share with you, just to give you a feel for what it looks like to fly a drone over a wetland. And in this case, we don't need the thermal because we're looking for the giant white bird that's getting ready to become pretty apparent on the true color. We do, of course, use the thermal to help us count how many young they have and other things, but these are breeding trumpeter swans on one of our wetlands. And as you can see, they're pretty conspicuous from the bird's eye view of a drone. So we also went back to all these wetlands to sample what I just call their ecology. So the things living in them, and to sort of understand the factors that may influence bird communities. Because I'm a bird biologist, so we're primarily interested in birds in this case. So we sampled fish. Now we're not interested in fish for fish sake. Most of the restored wetlands, or all the restored wetlands in this study, would historically not have had fish in them. Like we think of fish in most upland depressional wetlands, like those found in the prairie pothole region, as being sort of a artificial, like an artifact of modifications, like through drainage ditches and ways that fish can get around on the landscape. So we generally think of fish not being good for wildlife and wetland ecosystems. Though in the constructed wetlands, as you're going to see here in a bit, we're finding they're kind of built into the design, and their consequences maybe not as extreme as it can be in depressional wetlands. It would actually be an interesting research question in and of itself. But we sampled fish just to understand the ecology, what else is living in these wetlands. So we'll talk about the fish results. Then we also went to the wetlands to understand the vegetation communities at the site with a series of transects. So here's what our transects looked like. We put 3 different transects. These were randomized within the wetland, and then 4 sampling locations along each of the transects where we recorded the characteristic of the emergent vegetation at each point, the characteristics of submersed vegetation, vegetation that lives underneath the water and just flowers at the surface. And then we also took some water samples, and I'm not actually going to present any of the water data today, but we did that along those transects as well. So now in the rest of the time we have together, I'm just going to share with you what we found, just sort of admiring these systems and comparing the ecology between the two across the metrics that I just told you about. The first thing that I thought I would do is, here are 12 of the 46 wetlands we sampled. And I'm going to show you a lot of data, but I thought a picture is worth 1,000 words here to at least sort of get your head wrapped around the variety we found in our samples, both in terms of the water quality wetlands on the left and the wildlife or restored wetlands on the right. So just a pause here for you to sort of take in what these ecosystems look like. These are kind of representative samples from across our study. And now I'm going to show you a whole bunch of data. I'm going to show you a ton of box plots. And so to those of you that just had chills go down your spine because you've long forgotten your college statistics class, or maybe you were spared that throughout your life, let me just briefly remind you what a box plot shows. This is showing us the distribution of data. And so the skinny black lines at the top and the bottom are the range in which the top 25% and the bottom 25% of the observations occurred. And then the box in the middle shows the middle 50% separated at the median, the halfway mark of all of the observations of within the range of the metric that we're measuring. And so we can kind of look at the distribution of these boxes to give us a feel for the distribution of the measurements between the two wetland types. So you can kind of trust your eyes on this. I'm not going to bore you with a bunch of statistical tests or anything like that. I'm just going to let you sort of trust your eyes and understand the distribution of our data with these box plots. It's worth knowing that in this case, this slide here is just showing 46 data points, 23 for each, because these characteristics are fixed characteristics, but all of the other ones will show the distribution of data over both years. It's all just piled in together, just so you kind of know where we're headed. First order of business is this one. The conclusion here is that our wetlands were similar size, and remember, we baked that into the design. We wanted them to be less than 11 hectares. They were similar size, and they were in similar landscapes. So that's what those 2 figures on the right show. The one is the amount of cropland within 2 kilometers of the middle of the wetland, and the one on the right is the amount of grassland within 2 kilometers of the wetland. The reason we like this is this means that it sort of facilitates a direct comparison of the wetlands, the 2 different wetland types on all of the other metrics. We're not going to, for example, see variation in mallard abundance because of grasslands where the mallards nest, because there's basically the same amount of grass around all these wetlands. So onward to the rest of the comparisons between our wetlands and our study. Water quality wetlands were deeper than wildlife wetlands. You can see we express that in two ways. One is the average depth estimated across those transects, which in water quality wetlands was 0.8 feet. Versus 0.3 feet for the restored wetlands, in the maximum depth, which could have an impact on like overwintering conditions for fish. The maximum was 2.6, and actually we underestimated that because we never went over our waders, and so we truncated these a little. But the average max depth 2.6 feet in water quality wetlands, 1.2 feet in wildlife wetlands. Unsurprisingly, the deeper wetlands had more fish in them. That would be a permanence factor and also an ability for fish to survive winter. And what's depicted here is log transformed fish catch per unit effort. That's that figure on the left. Catch per unit effort just means how many fish we caught in 24 hours, basically. And you can see that we had lots more variation in the water quality wetlands. And we had just more instances where we found fish in the water quality wetlands, 2 times more actually. So 76% of the water quality wetlands had fish in them, whereas only 24% of the wildlife or restored wetlands had fish in them. And you can see their densities were obviously greater as well. Submersed aquatic vegetation also differed between these wetlands. Here we just pull a lake rake up along those transects, and so it's an index of how many times essentially we encountered submersed vegetation. So 4.5 means basically nothing, but it points to the fact that there's a lot more submersed vegetation in water quality wetlands than there is in restored wetlands in this landscape. And that could probably be explained by the fact that there's a lot more emergent vegetation in the wildlife wetlands. And so obviously submersed vegetation and emergent vegetation tend to not grow right on top of each other. And so we saw a lot more emergent vegetation in restored wetlands and a lot more open water, sort of the opposite of emergent vegetation in the water quality wetlands, depicted with these figures. And then finally, it doesn't really jump off the page at you with that box plot, but we did find higher vegetation diversity, more species of vegetation, and more sort of evenness across those species, a measure of diversity in the wildlife wetlands. They were more diverse than the water quality or constructed wetlands. On to the bird results. This is just a list. Wildlife ecologists are loath to just tell you what lists of birds we find because a lot of factors constrain our ability to see birds, and all of the rest of the results I'm going to show you account for our ability statistically to see birds through some like sophisticated statistical models that we use to try to estimate where we're missing things. But this at least gives you a feel for what types of birds we were picking up during those surveys. Most of the birds you note are black, meaning that we saw them on both, which is pretty interesting. We saw a wide diversity of birds on both of these wetland types. And then you see we saw a few more bird species on the water quality wetlands. Most of those are just migratory birds, so we were just picking them up during their transitions. And water quality wetlands are more open, and so they're just a little bit easier to see birds on. So that might explain that difference. And then those green species, green-winged teal is not a breeding species in Iowa, but all the other ones could have potentially been breeding here in Iowa. Well, I guess Wilson snipe would have been a migrant too, but the other ones could have been breeding, and we had some evidence of that as well. Now, more details on some of those species I told you we were going to square up to. This is output from one of those statistical models that I mentioned. And what is going on here is anything to the right of the line indicates a selection for or a preference for the wildlife wetlands. And anything to the left of the line, less than 0, indicates selection for or preference for the water quality wetlands, meaning Canada geese, trumpeter swans, wood duck, blue-winged teal, mallards, and hooded mergansers, all those birds we were surveying with the drone were all more abundant on the water quality wetlands. And marsh birds, all the birds we were surveying in the early playback surveys, they were all more abundant on the wildlife wetlands. We attribute this primarily to, in the case of waterfowl, the permanence of water is a place in late summer to raise your young in a wetland that holds water late into the summer. And so that's a preference for water quality wetlands. That's a pretty typical characteristic of them. And then in the wildlife wetlands, most of these bird species nest in vegetation. And so they needed that emergent vegetation that, as we showed, was much more common in the wildlife wetlands. So that's sort of the pattern that we find across the bird community. Here is richness. Richness is a term that we use just for like the number of species found on a site. And in this case, richness is the sum of all the probabilities of the species to occur on the different wetland types. And what you see here is just a different way of representing what we saw on the last slide. And that is marsh birds are more common on the wildlife wetland where there's more emergent vegetation, and waterfowl broods are more common on the water quality wetlands where there's longer hydro periods, where there's water for a longer period of time. And that's the difference, interestingly, is one species each. So you could extend this and just say like, well, species richness is basically the same on these two different types of wetlands. It just happens that one wetland is serving one group of birds better than the other. It's kind of an interesting parallel symmetry in our results. This is a lot, and this is just the species-specific results, and it's reflecting, these wide bars are just reflecting uncertainty and that it's kind of hard to pick these things up. But this is the species-specific results, and the biggest thing to take away from this is like some species were much more abundant, like wood ducks, for example, were much more abundant than other species like trumpeter swans that were more rare, using fewer wetlands. This is the last of our results on all of this, and this is again the product of kind of a complicated statistical model. But basically, anytime you see one of these dots on one side of 0 or the other, it indicates a positive if it's on the right-hand side, or negative if it's on the left-hand side, association with the variable in that plot and for that species. And I'll just show you these briefly. This is the marsh birds, and then this is the waterfowl. In our collective synthesis from these plots and all of our work is that specifically on water quality wetlands, there was more bird diversity on water quality wetlands that were larger, were shallower, and had more diverse emergent vegetation, which is kind of a cool result. It points to basically design considerations for getting the most out of these wetland ecosystems for both water quality and for bird habitat by finding ways to make them bigger, shallower, or have more diverse emergent vegetation. Our conclusions from this, of course, water quality and wildlife wetlands or restored wetlands are being used by many birds of conservation concern. We know wetlands are doing a lot of work for wildlife conservation and agricultural landscapes, and that's a really positive outcome. And it shows that water quality wetlands and wildlife wetlands are kind of playing different roles, or these small wetlands at least are playing different roles in these agricultural landscapes for different species of birds. They have different ecology, as I showed, different fish communities, different vegetation, and different bird communities resulting from that, which is interesting and worth noting. And that, to that last slide, certain features like size, emergent vegetation, and depth are consequential for bird use and could be the focus of future designs. Our last point is just that we're still working on these systems and still have lots of interesting questions that we're trying to chase down. We were in the field again last year, and I didn't include any of those data this time, but in the future, we'll have more to say about things like productivity. We want to know if those swans out there were actually fledging their young. So we're going to be able to monitor that. We're going to look at also other species of wildlife like reptiles and amphibians, and especially tuning into species of conservation concern, and then also grassland bird communities and the buffers around the wetlands as well. So with that, here's my contact information. And then at Matt's direction, I'm going to thumb through a couple of the Iowa Learning Farm slides as well, promoting future webinars and the CEU credits. And then I really look forward to questions that folks have or curiosities about these systems here in the time we have remaining. So thank you for the opportunity.
All right. Thanks, Adam. Yep, we're getting some questions coming in already. Let's jump to some of those next slides, though. Logistical, got to get
Oh,
through
yep.
those. Yep. Okay, if you are wanting a CCA CEU, please, excuse me, email Elena Whitaker, ALENAW at iastate.edu by 5 o'clock today. Include your name, the name you entered to watch the webinar, and your CCA number. Again, ALENAW at iastate.edu. Let's go to the next one. Okay, if you're willing, I can't say if you filled this out for 2025 because this is the first for 2025. But if you watch this webinar live and are willing to fill out a voluntary demographic survey, we'd greatly appreciate it. This is as part of USDA funded programs. So you can go to iowalearningfarms.org/survey, or you can scan that QR code. And only one for 2025 is needed. So if you do it for this one, you don't have to do it again in 2025. We can go to the next one. Okay, and we got Alex Schaefer, that's a senior research agronomist with the Iowa Soybean Association, is going to be talking about 2024 relay cropping management results. Relay cropping is a project where we at the Iowa Learning Farms are working with Alex on as part of a CIG project, or at least part of it. I think they're doing some other works, other aspects. And then is there maybe one more slide, Adam, on plugging? The webinars are all archived on the iowalearningfarms.org website, or there's a YouTube channel specifically for the webinars. And then put in a plug for the Regen PGC. Adam was on it before I even had to say go to the next one. Starting next week, tune in on the Perennial Ground Cover webinar series. Those will be on Tuesdays, starting next Tuesday. So please tune in for those. Okay, I'm going to take my prerogative as the moderator and ask the first question, Adam. So the results you showed were for 2022 and 2023, if I'm not mistaken. Were those drier than, like, as you looked at the maybe monitoring in 2024? Were some of the wetlands drier in 22 and 23 because of kind of drier conditions?
Yeah.
And do you think that would impact some of the results that you saw?
Yeah. Yeah, Matt, that's a great question. It's one of the reasons we're excited to have some long-term monitoring. We were able to get back to 18 of those water quality wetlands this year. And we're hoping to be able to get at least 5 years of data, sort of understand how their birds are coming and going on those sites. And yeah, drought would definitely have an impact. In fact, one of our ideas is that the water quality wetlands may be especially important in drought years for waterfowl broods, because they tend to go dry less frequently. I mean, I think they're designed as such. You'd be able to answer that, but they tend to go dry less frequently than even a natural wetland, and thus they may be the only water in the landscape, and that might be explaining some of these stronger associations that we found with waterfowl really rearing a lot of broods on these wetlands in the 2 years that we were out there that were rather dry. So good question.
Yeah. Is there a map that shows the let me see here, FWS wetland projects in their partners program?
I saw that question. I actually wouldn't be able to answer that question off the top of my head. I don't think that they would, because those are on private lands. But if you search for Drew D'Alessandro, who's the director of the Private Lands Partners Program in the state, you could find his contact information and check in with Drew as to whether or not there is. There isn't like a central depository of where restored wetlands are, and that was one of the challenges we sort of had at the conception of this project, to understand like where these wetlands come and go from. And that was what was cool about partnering with IDALS and Ducks Unlimited, was we were able to kind of get their records and then use that in this study design. So we would not have in this case been on partners' land, but the Fish and Wildlife Service partners started restoring prairie wetlands in the 80s and have done a lot of really good work in the U.S. prairies since. So great question.
Excuse me, I'm trying to go through. There's lots of good questions in here. Let me go. Oh, there were a couple about how, that some of the water quality wetlands are going to be receiving a lot of
Yep.
nutrients, specifically nitrate. How might that impact, I guess, wildlife being exposed to that?
Yeah, that's a really good question. And one that would definitely be a good future research question, like basically exposure to pesticides or eutrophication in the wetlands from nutrient enrichment. We didn't explicitly do that in this study. We didn't, we just looked for the presence of birds. And we say in wildlife ecology, presence doesn't equal productivity. We say that in grad school,
Okay.
actually, too. Presence doesn't equal productivity. And so that's a good question. We could be seeing these birds in these landscapes, but they could not be doing well there. Our intuitive sense is I don't know that that's going on. Wetland ecosystems are really resilient to like extremes, like extremes in nutrients, extremes in drought, and extremes in water inputs and other things. Like that's sort of the natural state of a wetland, is to be going through periods of extreme. And we find that wetland organisms are often pretty resilient to changes like that. And so my hunch to that question is that these animals probably are doing well. But I mentioned this interest in following up on swan productivity. Swans, we think, are going to be an easy model to study that because they're so conspicuous and they're so tied to a site. We're going to try to go out and like actually measure like nest success and brood survival and ultimately fledging of young swans on these sites to kind of get at that question of like, okay, they're there. Are they thriving there? It's a really important question.
Okay. Can you talk a bit about thoughts on how to optimize the future design based on your findings? And I think they're thinking maybe design of the water quality type wetlands.
Yep. Absolutely. And so a couple of thoughts on that. One, I also saw a question in the chat that I'll maybe start to talk about as well, about like small wetlands versus large wetlands. And so I'm trying to think of how to do this concisely. What we're studying is occurrence of a bird, which is definitely not the same thing as abundance of a bird. And so occurrence obviously increases with area, but abundance will also increase with the area to a point, and then it'll start to decline. Birds per unit area of wetland will decline. For example, take like Clear Lake, like picture Clear Lake in your head. There is definitely a mallard brood on Clear Lake in July, like no questions. But if you took the number of mallard broods divided by the area of Clear Lake, that number would be way smaller than the number of mallard broods on a like restored wetland outside of Clear Lake per unit area of that restored wetland. So occupancy, which is what I just presented on, would be the same, but abundance, and specifically abundance per unit area, would be lower. And so great question, whoever asked the question about area, because we do have to remember that sort of nuance. What I'm saying is, like, if we're taking drainage ditches, for example, or if we're taking outflow from subsurface drainage that already exists in a watershed and we're going to daylight it and treat it through a nutrient treatment wetland, which is a good thing for water quality. We know that. Those sites that are bigger are going to have more wildlife diversity on them. But this should not be taken as an endorsement of like draining extant wetlands, especially small wetlands, and doing what we call consolidation drainage. Taking many small wetlands and consolidating them into one bigger wetland is not going to be net positive for a bunch of things, including for wildlife. Because certain species of wildlife, including some of those that we studied here today, need small wetlands actually to complete their life history. And smaller wetlands tend to be fish-free, and fish-free wetlands tend to be better for wildlife. So that was my best attempt at distilling like a textbook worth of wetland ecology into an answer to that great question. If I was just designing a water quality wetland, I would design it in a way to try to get it as shallow as possible for birds, get it as shallow as possible, promote conditions that promote emergent vegetation throughout the pool. We don't want it to be covered with emergent vegetation, but some intermediate amount of emergent vegetation in open water is best for wildlife. And then the larger, the better in terms of building these wetland ecosystems. So,
Okay. Have you and or your team installed any bird boxes to potentially attract a variety of bird species to any of these sites?
yep.
Or have,
We haven't. It would be actually a really interesting way to study these sites experimentally. I don't know if you all noticed, but like on the slide, I'll just jump to it with the species, and there's a lot going on here. But the most abundant, the most likely bird to be found on every single wetland in Iowa is a wood duck. Excuse me, every single water quality wetland. And I attribute that entirely to the tendency for landowners to build wood duck boxes.
okay.
And so it would be a fascinating study. But of the species on this list, wood duck and hooded mergansers are the only two that would nest in a box. And of wetland birds, generally, the only other one that would nest in a box would be tree swallows. Everything else generally builds its nest in wetland vegetation or in surrounding grasslands. And so there's not a lot of opportunities in wetlands to increase use with boxes other than wood ducks, hooded mergansers, buffleheads, and tree swallows.
Okay. What was the most common submerged aquatic vegetation that you found?
I saw that question from Jackie, thought it was a great one, and thought, I hope Matt doesn't ask me.
Oh, okay. All right. All right. Well, I had to make sure Jackie Couch got one of her questions in.
Thanks for coming in. Coming in with that one, Jackie. I don't know. This is what happens when you have the faculty member that drives the desk and runs the grants give the talk. We only sampled submerged vegetation for biomass. So we were only like recording the biomass that came up on our lake rakes. We weren't recording the species. But let me say, Jackie, that Brian Wilsey, who's a bona fide plant expert, not a bird biologist masquerading as one, like present company, is doing a much more rigorous assessment on something like 25 CREP water quality wetlands in Iowa. They were in the field this year, and they'll have more to say about the species composition of the submerged vegetation soon. So I'm not even going to wager a guess. I have a hunch, but I don't think I need to say it necessarily and risk being totally wrong. So
yeah, that's like a good plug, Adam, for us to get
Brian.
For Brian. Exactly.
Perfect.
Exactly.
Great idea.
Well, there was one other question about that Jackie Couch asked about the mesh size of the fish nets. Did you catch any aquatic invertebrates?
Yeah, we did, and we did like large dragonflies. We were recording larval captures, but it was not designed to sample aquatic invertebrates. So these were mini pike nets that do have really fine mesh, like a single digit millimeter mesh. So we were definitely catching small things. I didn't present any of those results because, like I said, it wasn't really designed to be an invertebrate study. But here's another plug. Dr. Charlie Lowen is studying aquatic invertebrates and plankton communities in water quality wetlands right now, and would be a great person to have on the webinar series as well. Just like Brian is going to paint a much more complete picture of the plant communities at these sites. Dr. Lowen and his students would be able to paint a much clearer picture of the invertebrate communities in these sites based on their sampling from this year and future years.
Awesome. Thanks, Adam. On another plug, and we'll have to get those folks to present when they have some data to present. Are there comparable remnant wetlands to use as control?
Yeah, it's a great question. We chose to focus on restored wetlands because we just thought that was kind of more interesting. It's like land coming out of agriculture and back into wetland ecosystems. But comparing wetland ecology to remnant wetlands would certainly be an interesting study as well. Many fewer remnant wetlands or undrained or unmodified wetlands left in Iowa's landscapes. But one could certainly find them in certain places like Dickinson County comes to mind. Like that's kind of the place where we'd expect to see the most. I'm trying to think around here. I mean, Doolittle Prairie has some wetlands, but they have what we call seasonal hydrology. So they don't, all these wetlands were semi-permanent hydrology, meaning they stay wet in most years for most of the growing season. Doolittle Prairie has remnant wetlands, but they would be seasonal. They are only wet early in the year and wouldn't be good to compare to. So it's a good question. There's not many that aren't impacted. I even think like Bork Boda Marsh is a popular marsh relatively nearby Ames here. And it has a drainage ditch that goes into the backside of it. Like it's been subjected to hydrologic modifications. And then the watershed in Iowa's, or excuse me, the water table is so extensively modified by subsurface and surface drainage that basically every wetland ecosystem has been impacted in some way.
Yeah.
Good question, but probably not enough scale to do the type of wildlife study that we do.
Has anybody looked at what the cost difference is between the, say, the water quality and the wildlife wetlands?
Yeah. I can only speak in generalizations because, of course, I'm not on that side of the equation. Like I'm on the research side. And folks from IDALS and folks even better from Ducks Unlimited, because they're doing kind of both of these sides more regularly, would be able to speak to that. But as I understand it, a restored wetland is generally easier to create than these water quality wetlands, because by definition, the restoration is occurring in a place where water wants to be on the landscape. Like the soils are hydric, like inclined to hold water. And then also you just have to remove the drainage infrastructure, like pouring vials of soil, like I showed you from North Dakota, into a drainage ditch, and then bringing a bulldozer along to do the same. It creates a wetland, as long as there's not subsurface drainage. Whereas these water quality wetlands, as you can see from the picture that's up on the slide right now, have a lot more infrastructure along them to stop a creek or to stop a low area where drainage tile has been daylighted. So I think, as I understand it, these water quality wetlands tend to be more expensive than restored wetlands. But the upside is that these water quality wetlands are put lower in the watershed where there's a lot more nitrogen in the water because it's draining more area upstream. And so restored wetlands generally are higher in the watershed. They're receiving less nutrient-rich water. And so, yes, they're doing all the water quality good. They're just not doing it at sort of a disproportionate scale. And that's like the pitch or the value proposition of these constructed wetlands in our really modified landscapes, is that we can put them in a strategic place where they're going to get a whole bunch of water from a whole bunch of ag fields and facilitate that natural denitrification process and then send that water along the way. And natural wetlands aren't necessarily going to be receiving that high nitrogen load water in the same way.
Great. Okay, there was a question here on your thermal images, so maybe you can go back to that.
Yeah.
They wanted to make sure that whether it was the white or the black dots that were the birds.
So I have to hit play on both of these at the same time.
Okay.
But if you can see, I hope this is playing okay.
It is. Yep, I think it is. Yeah.
So it's the same birds in the left and in the right. And so you can see like now it's turned, the right one is just a little bit behind. I just can't get PowerPoint to play them at the same time.
And so it's those kind of white features moving.
The white features on the left are the brown features on the right that you can see of this brood. And so then once they get up in vegetation, you can see those white figures really stand out pretty well in the water.
Whereas in the one on the right, you
can't
can't hardly see them anymore. Yeah.
So we go look for birds with this thermal camera, and it allows us to increase the probability that we're going to see things. And like I said, I was hinting at this, we use all these statistical models to try to account for things that we can't see. Like that's really what a wildlife ecologist does, is we try to count things we can't see. The drone gives us a leg up and lets us see a few more of these birds. And you also don't have to go kicking through a wetland in July, which we like for other reasons.
Yeah. Another maybe kind of one last one. The crepe style wetlands typically experience more fluctuations in depth over the course of the year. Do you think that may have increased the prevalence of some shorebird species?
Yeah, that's an interesting thought. I will say, like, those shorebirds that I showed, like we just happened into those. If we were designing a study to look at shorebird use, we would design a totally different study. Like we would survey them at different times of the years and we'd use different methods, frankly. And so I have I'm doing like the classic scientist, like, oh, we should do that study. And I do think we should do that study. Like there are interesting questions about um uh migrant use of these wetlands that we have not even
Okay.
started to square up to. We're only looking at breeding bird use. And there would be a lot more species that would be using these during migration. So interesting questions. Water level fluctuations. I'm interested if the person that shared that, I'm wondering like if they have firsthand experience with these wetlands or what, because I've meant to instrument these and try to figure out how extensive the water level fluctuations are, but I haven't yet done that. And maybe Matt or Bill or somebody
Yeah.
would be able to speak better to how extensive those are. But my personal impression is that we're not seeing a lot of like what we call exposed mud flats
Yeah.
along the margins of these, except in the dry years where they like are actually
Yeah.
drying out. And so I don't know about shorebird benefits for water quality wetlands. It would be something I'd definitely be interested in looking at more, but right now we really just don't have much data. And having, you know, walked around a bunch of these, I don't see a ton of potential for shorebird use. But I could be wrong there
Yeah.
for sure. So we did see one of those was a blackneck stilt, which is a super rare bird, which is kind of cool. And that's just like those birds got blown north, and we just happened to be at the wetland the day they were there, which is just kind of a cool observation.
All right. I think in the interest of time, we will end it there. Um, Again, if you want a CCA CEU, please email Elena Whitaker, ALENAW at iastate.edu by 5 o'clock today with your name, the name you entered to watch the webinar, and your CCA number. I want to really thank Dr. Janke for excellent presentation and also plugs for getting us thinking about other wetland presentations on some of the other aspects. And so with that, I'll give Adam the last word.
Well, yeah, thanks for the opportunity, Matt. And I do see a bunch of questions. If I could get those, I can um,
I'll send them to you.
okay,
Yep.
perfect. And
Yep.
if I can figure out a way, and thanks folks for
Yeah.
tuning in and yeah, feel free to shoot me an email. My email is up here. Shoot me an email if you have questions about this work and definitely happy to keep the conversation going. So
Okay.
cool. Thanks everybody.
Yeah.